Have you ever stopped and wondered where the whole idea of AI even came from? I mean, really began. It wasn't in some slick, modern lab filled with supercomputers. Nope. It all started back in the 1950s with a machine that was actually taught to think. This is that story.
You see, it all kicked off with this one huge question that a new wave of thinkers were obsessed with. Instead of just programming a machine with rigid step-by-step instructions, what if you could build one that learned from experience? One that could get smarter all on its own, kind of like we do. So, to even begin to answer that, we have to jump back in time, back to the dawn of the computer age, and meet the guy who had the guts to try and build a brain out of wire.
Okay, so picture this. It's the 1950s. Computers are these massive, room-sized monsters. What you're looking at here is the IBM 704, an absolute beast for its day, capable of crunching up to 40,000 instructions a second. And it was on this very machine that one researcher was about to try and spark a completely new kind of intelligence.
And the mind behind this whole crazy idea? A computer scientist from Cornell University named Frank Rosenblatt. And let me tell you, he wasn't just some stuffy academic. He was a true visionary. Rosenblatt was a character, for sure. He zipped around in a classic sports car, taught this wild course that blended biology with engineering, and had this huge ambition. He wanted to figure out the fundamental rules of how everything learns, whether it's made of human cells or electrical circuits.
And that huge ambition, it led him to build something the world had literally never seen before, the very first learning machine. He called it the Perceptron. This thing was a complete game changer. It wasn't just a fancy calculator. It was the first machine ever designed to learn new skills using what's called a neural network, a system that was directly inspired by the wiring of our own brains. So how in the world did it work? Well, at its heart, it's a decision-making machine. You see on the left, you've got your inputs. Think of them as pixels from a picture. That information then flows through this web of connections. Now here's the key. Each of those connections has a weight, which is kind of like a volume knob. It can turn signals up or turn them down, making some inputs way more important than others. The network then just adds up all those signals and spits out a final decision on the right. And here's the coolest part. The Perceptron learned the exact same way we do, trial and error. You'd show it something, it would take a guess, and if it was wrong, you'd tell it. But the real magic is in what it did next. This is basically the rulebook it used to make a choice. Think of it like a vote. The machine adds up all the signals coming in, each one cranked up or turned down by its weight. If that total score crosses a certain line, a threshold, it votes yes and outputs a 1. If not, it votes no with a 0. So simple, right? But so powerful. But this right here is where the real magic happens. This is the error correction formula. Whenever the Perceptron got something wrong, this rule would kick in. It would actually go back and tweak those little volume knobs, the weights that led to the mistake. It would turn some up, turn others down. So with every single mistake, the network was literally rewiring itself. It was getting smarter. It was learning. The Perceptron created this massive wave of excitement. I mean, it really felt like the dawn of thinking machines was right around the corner. But then a book was published, and it brought everything to a screeching halt. So in 1969, two heavy-hitting researchers from MIT, Marvin Minsky and Seymour Papert, they published a book called simply Perceptrons. And their critique would end up casting this long, dark shadow over Frank Rosenblatt and all of his work. And look, this wasn't just some minor academic squabble. This book was a landmark event. It basically went through and systematically dismantled all the hype and excitement around these early neural networks. Minsky and Papert used some seriously rigorous math to prove that Rosenblatt's simple single-layer perceptron had a fatal flaw. It was fundamentally limited. It couldn't even solve some problems that seemed really basic. Their critique was so powerful, so devastating, that it pretty much convinced the entire research world to just give up on neural networks, kicking off what we now call the first AI winter. This huge professional setback was followed by a personal tragedy, and it looked like Rosenblatt's ideas might be forgotten forever. But this is the story of his legacy and the long, slow comeback of his creation. It's just so tragic. Only 2 years after that book came out, Frank Rosenblatt died in a boating accident on his 43rd birthday. He never got to see his vision truly take flight or defend his work. For a long time, it seemed like his groundbreaking ideas were just buried. But great ideas have a funny way of coming back. As you can see here, that AI winter lasted for years. But then, by the 1980s, a whole new generation of researchers had a breakthrough. They realized Minsky and Papert weren't totally wrong, but they were only talking about Rosenblatt's simple model. What if you stacked these perceptrons into multiple layers? Well, it turned out you could overcome those limitations entirely. The AI winter finally started to thaw. And then, decades after he was gone, came the ultimate recognition. The year was 2004. The IEEE, which is the world's largest technical professional organization, a huge deal, they created the Frank Rosenblatt Award. It was this formal, powerful acknowledgement of his foundational role in creating the very field that had, for a time, turned its back on him. His legacy was finally set in stone. So why does this story from over 60 years ago matter to you right now? Well, because the ghost of that very first learning machine, it's all around us. I mean it. Every single time you use a translation app, or see a video recommended for you, or hear about a self-driving car navigating a street, you are seeing the direct descendant of Frank Rosenblatt's Perceptron. The massive, deep neural networks that power our entire modern world are all built on the exact same idea he pioneered, that a machine can, and should, learn from its own mistakes. Rosenblatt's story is just this incredible reminder that progress is never, ever a straight line. Ideas get dismissed, pioneers can be forgotten, but a truly powerful idea, well, that can echo through the decades. His dream was put on ice for a while, but it was never wrong. It was just ahead of its time.